My name is Maria Silveira. I'm a soil scientist. I also want to introduce two special people here. Yin Lu. She's a PhD student in my program, so all the data that I'm going to share with you today came from Yin efforts. She's graduating next semester, probably in February next year. She'll be finished with her PhD program. And she worked, during her PhD, she worked in this Biosolids project that I'm going to present. If you look on the other side of the fence, that's where the experimental area is. I also want to introduce Leandro Vieira. He's also a PhD student. He recently joined my program, and he's going to continue the work that Yin started. We're going to change some of the research questions, but he's going to continue the work on biosolids. So last field day, I talked this biosolids. I didn't have this biosolids project. I didn't have much data to share with you, but I'm happy to say now we have some published data. Yin is in the process of publishing some of her results on water quality. And the issue that we're trying to address here is water quality and how that relates to pasture fertilization. I think the reason why I was hired in my position was because of the public concerns regarding pasture fertilization and the potential negative impact on water quality. And there continues to be at least a perception, especially among the non-ag groups. They think that pastures are heavily fertilized. Fertilizer doesn't cost much, right? So farmers are dumping as much fertilizer as they can in the pastures. And the reality is completely different. Fertilizer costs a lot, and we're trying to provide tools to help the ranchers determine when and how much fertilizer is needed. So it's a very, very touchy subject in Florida, especially when you talk about phosphorus fertilization. There's so many water quality issues that's being related to ag phosphorus fertilization. So that was the idea of establishing this field study. Field studies are not easy to manage because it requires a lot of labor, money. So I've been fortunate that the Florida Cattlemen Enhancement Board funded this project. If you look at the plot, it doesn't look like it's just grass and some flags and maybe some instruments sticking out of the ground, but I can tell you that's worth, in terms of instrument that's being installed in this field, there's more than $100,000 worth of equipment. So it's a well-instrumented field. We are able to monitor water quality, gas measurements. This is some of the instruments that are installed in the field. So we have lysimeters to measure the water that leaches through the soil profile. There's a pressure transducer, basically measures the depth of the water table. So the time of the year where the water table is close to the surface, that's where we have a greater likelihood of nutrient transport, mainly nitrogen and phosphorus. Yin also has some gas chambers. So periodically, sometimes it's bi-weekly, sometimes it's once a month, depending on the time of the year, she comes here and collects gas samples. So it's a heavily instrumented field. And we are also looking at the forage responses, because it wouldn't make sense to only focus on the environmental. If you don't have any agronomic benefits, farmers will not be able to use this. So what we're trying to address here is commercial fertilizer is extremely expensive. What are the alternatives to reduce the dependence on commercial fertilizer? In this case, we are using biosolids. Biosolids is a byproduct from the wastewater treatment, and there's a lot of misconceptions surrounding biosolids. A lot of people think that they are contaminated with heavy metals, which is not true. They also think there's a lot of organic contaminants, which also not true, not based on data that we are generating, but also data from elsewhere. So what I want to show you today, we established this in 2016. We've been collecting all these measurements since 2016. We're towards the end of the 4th year of the study. We're going to make some changes in the treatments, and Leandro will continue with the study. But I want to show what we gather in terms of data so far. So if I replace commercial fertilizer with biosolids, would Bahia grass perform the same way? Would my herbage accumulation, the nutritive value, crude protein, digestibility of my forage will be the same? And the answer, yes, it is the same. So I'm going to show just the data from 2017. And what I'm showing these bars here, this is Bahia grass production in pounds per acre in the first harvest, second harvest, third harvest of 2017, And here's the cumulative amount of forage produced. You don't have to really read what I'm saying here. I'm going to summarize this. What happens is commercial fertilizer, the nutrients present in commercial fertilizer is readily available. So the plants, once you apply to the pasture, given that there's enough moisture, plants will be able to utilize, and they'll probably accumulate more mass, more biomass. Biosolids is a little different. Most of the nitrogen, for instance, in the biosolids is in organic forms. Plants cannot utilize organic nitrogen. So the organic nitrogen needs to go through several processes, mineralization, in order for the plants to be able to utilize. So what I show in this picture, and you have to believe me for those who cannot see, the first harvest of the year, which is usually in the spring, biosolids produce less, Bahia grass production was less for the biosolids treated plots, because the nitrogen was not readily available as compared to the inorganic fertilizer. Towards the end of the growing season, the situation was exactly the opposite. Because of the slow release nature of biosolids, they were able to keep Bahia grass production over the entire growing season. So when we look at the overall production for the year, there was no difference between biosolids and commercial fertilizer, which is great. Biosolids is usually most farmers can get for free. So it's a good way to save money and not buy fertilizer. I mentioned that another goal was to look at nutritive value. I'm just going to show you crude protein. I have crude protein and digestibility here. Basically, there's no difference. This is control with no fertilizer, and the other bars are either different types of biosolids or commercial fertilizers, the blue bar here. So in general, there's no difference in crude protein or nutritive or digestibility among these different sources, which is also good in terms of agronomic responses. That's exactly what we want. But how about now? How about the water quality? If we can find it here. Here. Any of these benefits will make sense unless if there's no environmental impact, right? If we know how to produce forage, we can apply a lot of nutrients, and we know that most of the grasses will respond. The question is, what are the environmental impacts? How that fertilization management can potentially affect water quality. So water quality it was a main focus of this study, and let me tell you, there's no other study was done under field conditions with biosolids in Florida. For the folks here that use biosolids, you're probably aware of the fact that DEP is changing the biosolids regulations for land application. I suspect that land application will be very difficult to happen in the future. The regulations are going to be stricter. And unfortunately, our data doesn't show that the biosolid is cause a main issue. So let me focus on the phosphorus, which phosphorus is usually the biggest concern in South Florida. I know that you're not going to be able to read this, but let me just tell you that these green dots here are commercial fertilizer. We are applying phosphorus at a much greater rate than what we would normally recommend for cow-calf, a pasture, established Bahia grass pasture. So you see over the course of this is 3 years of data from 2016 to 2018. There's some spikes in this case it's phosphorus, some high concentrations of phosphorus in the water during certain times of the year. And those times usually overlaps with the time when the water table is close to the surface. So we know that every time that the water approaches the surface, it also brings a lot of nutrients with it. Interestingly, you don't see the spikes in the plots that are fertilized with biosolids. And now you're going to have to trust me. The biosolids are the yellow lines here, the yellow dots here. So you don't see the yellow dots sticking out in this graphic here. So basically, again, because of the slow release nature of these biosolids, they provide a constant source of nutrients to the crop throughout the entire growing season. And we didn't see these spikes in nitrogen or phosphorus for the biosolids. So from an environmental perspective, biosolids is a much better choice of fertilizer source than commercial fertilizer. We also have some gas measurements, and basically the graphic is here, but basically shows the same. There's some spikes in nitrous oxide is a big concern. There's no environmental regulation right now, but I suspect in the future we will be talking about air quality as well. So we have to have the science behind us to show that these practices, if they're done in a proper manner, they cause no environmental impact. So Yin is in the process of publishing this. I have a couple individuals that ask me where they can find this information. Some are published, some are still the water quality we haven't published, but I'll be happy to share this information with you. Is there any questions that I can answer?
I've got one. What
Yes.
was your source of biosolids? You mentioned people worry about metal toxicity. So what did you use for biosolids so you eliminated that concern?
Okay, the question was what type of biosolids I was using, specifically how that relates to potential heavy metal contamination in the biosolids. We use 3 types of biosolids. We use 2 Class B and 1 Class A. So in Florida, biosolids, the way they are regulated is based on, they are either Class A or AA or Class B. 90% of the land application and occurs in pastures, that's the main crop, and 90% are Class B material. So the difference between a Class A and a Class B is not is the amount of pathogen. So Class B, there's some restrictions. I don't know if you noticed when the wagon turned in this pasture, there's a big sign, biosolid. We are standing on a biosolids application site. Don't worry, you're not gonna be contaminated with anything. So there's some restrictions, for instance, grazing restriction. You cannot graze the pasture for 30 days after the biosolids application. In terms of heavy metal concentration, since the Clean Water Act in the early 70s, when municipal and industrial wastewater was treated in the same facility, we had issues with heavy metals. And if you look even now in 2019 in the scientific literature, there's some countries that treated their wastewater together, the industrial and the municipal. So in some countries, heavy metal can be a concern in biosolids. In our case, in the United States, because of our regulations and the way that we treat our wastewater, we don't have any heavy metals. In fact, Ying run heavy metals, and she also run some of the metals in the bahia grass tissue, and they are background levels, so they are not elevated. And she also run the heavy metals in the soil, they are background levels. We decide to use sources that most of the producers around here, biosolid source that most of the producers use. So we use one Class B material from Bradenton, one was from St. Pete, and a pelletized material. You can buy this at Home Depot. This is yeah, some people get food. Oh, it's organic, but this is biosolid. It's a pelletized material. It's the same as the stinky sludge that you buy. The only difference is it's being heat dried, and it's a Class AA. And this one, most likely you're not gonna get for free. The Class B you're gonna get for free. In terms of nutrient release, if I show you again this graphic here, well, this graphic is an average of 4. But what I can tell you is there is no difference in the amount of nutrient, nitrogen and phosphorus that leached from this material from the cake that come from Bradenton. As long as we are following agronomic practices, we're not dumping, we're using biosolids as a source of nutrients, applying at agronomic rates, it doesn't cause any environmental problem. But the problem is when it's overused, and I think anything in life, if you overuse, can become a problem. Biosolids is in the same category. Any questions? So the question was how biosolids application rate and frequency, how much you apply every time and how many times a year you do. If you are, the recommended, a DEP dictates what you can do. So if you are in an area where you can apply based on the nitrogen requirement of the crop in the bahia grass, the highest amount of biosolids that you can apply is 240 pounds of nitrogen per acre per year. So this is DEP that dictates that. It's based on the highest nitrogen fertilizer recommendation for established bahia grass. The frequency, it usually is not, if you apply the high rate, you only apply once a year because you're meeting your annual load. If it's economically viable for your property to split the application, yeah, there's some benefits associated with that, but we don't. It will depend on how much you decide to apply each time, and if you are If a hauler is applying the cake biosolids, most likely they're not going to come twice to your property to deliver the product for free. So in terms of practical implication, it's usually done once a year, and usually the highest application is around 200, 240 pounds of nitrogen per acre per year. Yes. The comment was, wouldn't the split application be detrimental, because not all the nitrogen is going to be readily available. So plus you have the 30-day grazing restriction. If you are looking at the long term, if it's not the annual basis, if you're looking at the split application may make sense. But if you are doing one-time application and you are looking at that particular growing season, definitely it's not a good idea to split apply. And to be honest, I don't see any benefit in even from the agronomic standpoint, because the plants are actively growing and they are using all the nutrients. So there's let me show you one more thing. The 2018 data, towards the end of the season, most of these grasses are gonna go dormant anyway. Yeah, this, I don't know if you can see this, but this is when we harvest in December. So there's really, doesn't matter what fertility management you are using in December, this is December harvest. These plants are go dormant in December. So you usually, no matter what you do in terms of management, you're not gonna get a lot of production that time of the year. So yeah, we're trying to focus on the spring season. That's where we need most of the forage. The question was, what is the typical nitrogen concentration in biosolids? It varies. The nitrogen is between 3 and 5%. This is relatively constant. What it varies a lot is the moisture content. So you can have anything from, this is 90%, 10% moisture, 90% dry matter. You can have materials, the cake that we apply here contains 85% moisture. So the tonnage, the amount of material that you have to apply is much more because you're applying a lot of water. So that's why it's important, if you are buying a class A, let's say material that is being composted, and you say, well, you only cost X dollar per ton. It seems relatively cheap, but if the material contains 80% moisture, you are paying a lot for water. So trying to calculate how much you are paying per pound of nitrogen, or of course there are other benefits. You're also applying phosphorus and the organic matter. There's a multitude of benefits in applying organic, but be careful because sometimes you're paying a lot for water. Even the composted material contain a lot of water, so it's important to keep in mind that. The question was, is biosolids a complete source of nutrients for pasture, or do I have to apply something additional nutrients, right? No, usually what this grass require the most is nitrogen and potassium. In our case, we've been running this study for 4 years, and the only thing they've been receiving is either biosolids or inorganic fertilizer. So inorganic fertilizer, if they are also well balanced, it should provide 100% of the crop needs. Biosolids the same. If they're applying the right rate, you don't have to supplement. Only exception is if you are in a very, there are some areas in the state where you're not allowed to apply the 200 pounds that I mentioned, 200 pounds of nitrogen to the acre. Because of phosphorus restriction. You can only apply biosolids based on the phosphorus requirements of the plant. That means that the plants will not get the amount of nitrogen that they need. That means you're probably going to have, if you want to optimize your production, you're going to have to apply commercial fertilizer. And that's not a very attractive option because you don't want to apply biosolids and still have to buy commercial fertilizer. Not many people, I honestly don't know any commercial ranch that does that. Apply biosolids and supplement the biosolids with commercial fertilizer.